This is our secret ingredient. This is the sorbent that we use to capture CO2 from the sky. And in this episode, we will answer the question, how does Carbyon solution work? Hi, I'm Beatrix and I work at Carbyon. And in this Ask Carbyon series, we answer questions about capturing CO2 from the sky. Because we get many questions, we thought it's time to answer them. So together with experts, we explain how Carbyon is working on a solution. And in this episode, we have invented a great technology to capture CO2 with.
Much more cost effective.
It's going to look completely different than what you see here today.
In episode 1 and 2, we have explained what direct air capture is and why we need it. And there are multiple companies in the world working on this. So is Carbyon, because we think we have invented a great technology to capture CO2 with. And how it works, you will learn from my colleagues. Let's start with the founder of the company, the innovator, the father of the Carbyon family, Hans de Neef. You are not the first person to think about direct air capture. There are actually already working installations, but they are relatively small. Why aren't we doing this on a large scale yet?
The reason is it's very expensive. And the current systems cost between $300 and $1,000 per ton of CO2. If you would translate that to a liter of gasoline, that would up to 90 cents per liter of gasoline. I think nobody would be willing to pay for that. So it's too expensive. The challenge is to get it more cost effective.
So how is Carbyon going to change that?
We came with an invention how to make the material that reacts with CO2 much faster. So we developed a sorbent that takes about 5 minutes to saturate itself with CO2 instead of the 5 hours, which is, let's say, the current state of the art. And if you can translate a process from 5 hours to 5 minutes, you can make a machine which is much smaller for the same amount of output and therefore also much more cost effective. And that's what we do at Carbyon.
And we often get the question, when is your machine ready? So how far are we with Carbyon?
We already made a first prototype that can process up to 1 cubic meter of air per second, reaching a capacity of 2 tons of CO2 per year. It's available in the lab, and Jasper is waiting there to explain all about it.
So before we enter the magical lab, don't forget to subscribe to the Carbyon channel for more future lab tours. Hi Jasper, can you maybe explain us how does this work?
This is our new test setup. It's called Wally, and it works with a big fan outside, which transports the air from outside into the machine through the tubing, and then goes into the reactor right here. And the reactor is what contains our sorbent. Now the sorbent captures the CO2, but all the other air is blown back outside again. Now after the sorbent is full, then we close the reactor, we heat the sorbent and the CO2 is taken out. And then we open it back up again and do it all over again.
Easy as that, right?
Indeed. And the test results from this machine we will use to support the design of the full-scale machines in the next phase. Now those next machines will be used in the field to test with partners as pilots. And after that, we are going to redesign it for mass manufacturing and produce a lot of them.
But one of the questions I still always get at birthday parties is, what will it look like?
It's going to look completely different than what you see here today. This is a test setup with a lot of additional sensors, and we're not going to place this in the field. So the real machine that we're going to build is going to be much larger. It's going to be the size of a shipping container, which is about 2 by 2 by 6 meters, put upright. When they are placed in urban areas, we'll make sure that they blend in with the environment, but most of the machines will be placed in remote locations.
What are the ideal sites to place these machines?
So in terms of the availability of CO2, it doesn't really matter, because the CO2 concentration is pretty much the same everywhere in the world. So instead, we have to look at locations where there's a lot of green, renewable energy available for a low price, such as deserts for a lot of sun or windy areas. Now the location should also be based on where we use or store the CO2. As for usage can be synthetic fuels, greenhouses, making chemical industry.
Whoa. Let's hold that for episode 4, where we will explain more about what we can do with the captured CO2. And there are many cool things. For now, thank you for watching, and I hope you have enjoyed it. Let us know in the comments if you have more questions. Bye!